This video is going to be over the dose calculation at depth of maximum dose, except here, rather than discuss problems 1 and 2, we're going to be going over 3 and 4. This is for the Cobalt 60 beam as well as a linear accelerator. These problems are from Bentel, chapter 4, I believe. So if you want to cross-reference that with the material, that's where it would come from. So Cobalt 60 beam is used to deliver 200 centigrade at Dmax. The field size here is going to be 10 by 12, and the SSD is going to be 80. So the dose rate for a 10 by 10 field at Dmax is going to be 112.7 centigrade per minute. And the area factor for a 10 by 12 field is 1.02. So what treatment time is needed to deliver this treatment? All right, so the time is basically going to be equal to the prescribed dose divided by the product of the dose rate and the area factor and the percent depth dose. So here you're going to see 200 centigrade. That's what we want to deliver at Dmax. This is the dose rate that is given, which is the 112.7. Multiplied by the area factor, because this is a little bit larger than the field that we're referencing. And since we're at Dmax, the percent depth dose is going to be 1.0 because it's the maximum. We're not having to scale it down any. So when you go through and you do the calculations here, you end up with, let me check that just to make sure that's the case. So let's see, if I take 112.7, tell you what, let me run the calculator here so you guys can see what I'm doing. So according to this, 112.7 multiplied by 1.02 should be 114.954, which is in fact what we have. I mean, I got multiplied by the 1 again, but we all know what that is. So if you take 200 and divide it by that, let's see if you come up with this. 114.954. I'm going to put this over here. Clear out everything. So I've got 200 divided by 114.954. And you come up with 1.7398, which is around 1.74 minutes. Now, how do we figure out exactly what all of this number, which is a long decimal, how many seconds that is? Well, strip off the number of minutes, anything past the left side of the decimal there. So I'm going to subtract 1. Got that. And then take that and multiply it by 60. And that'll give you the number of seconds. And in this case, they just round it down. So there you have it. I really should not have closed that. Let's see. So let's just minimize it. All right, for the linear, pardon me, linear accelerator. So we got a 4 MV photon beam that's used to deliver 200 centigrade at Dmax. Field size is 15 by 15, and the SSD is 80. The dose rate of reference is 1 centigrade per monitor unit for a 10 by 10 cm field. This centigrade per monitor unit for, or the centigrade per monitor unit for a 15 by 15 centimeter field is 1.037. So what MU setting should be used to deliver this treatment? Okay, well, the number of MUs is going to be equal to the prescribed dose divided by the product of the dose rate at reference, and then the dose rate per MU for the treatment times the percent depth dose. Now, what does all of this mean? Well, we know this particular value because this is standard. Usually a 10 by 10 dose rate at maximum is what we're referring to here. Now, we're not treating with the 10 by 10, we're actually treating with the 15 by 15. So what do we need to do? We're going to need to scale that. And we're going to scale that by the 1.037, because what this is saying is that we're going to receive more dose in for this particular field, more centigrade per monitor unit than what we would here. So we're putting that in, multiplying it by that, and then multiply it by the PDD. Well, the PDD, since we're delivering at maximum in this case, is just going to be 1. So in this particular case, we've got 1 times 1.037 times 1. So on the bottom here, we're just going to have 1.037. We're going to take that 1.037, divide it into 200. And we end up with 192.86 or 193 monitor units. So that's where this particular value comes from. So I hope that that video kind of cleared up any confusion you might have had.